On the north coast of Northern Ireland, just off the popular seaside resort of Portrush, lies a group of islands known as the Skerries. Until very recently, nothing was known of the life in the sea around these craggy rocks, normally visited only by gulls. In the summer of 1979, a diving team from the Botany and Zoology Department of the Ulster Museum came to investigate. Specimens of the animals living at each dive site were collected and brought back to the mobile laboratory at the Portrush Countryside Centre. Here the specimens were preserved, registered, catalogued and fully documented. It's extremely important to have all the information about a specimen and the site it came from kept with the specimen to avoid later confusion. One of the major problems on a survey such as this is the identification of the material collected. A very wide variety of animals, from sponges to fish, are inevitably recorded, and often quite obscure species come to light. The literature available for full identification of marine animals is extremely complex and scattered through many sources. Where a real problem arises, the specimen is retained without a full identification for later work and, if necessary, reference to an authority. The object of an exercise such as this is to provide baseline information on what animals are present in a particular area. We in the Ulster Museum are involved in carrying out such work in a different area each year to attempt to gradually build up a complete picture. If someone comes to the museum in 100 years, they should be able to check on the actual specimens collected at the Skerries in 1979. In all work of this nature, photography, routine lab work, documentation, and chores like washing equipment must go hand in hand with the actual diving activities. Early each morning, the boat is brought round to the small Portrush harbour from its safe overnight mooring in Portrush. After having breakfast and loading the boat, we head out for the day's diving. We now know approximately what the situation is in the Skerries. We have the large Skerry running along to the small Skerry and another group of rocks called the Otter Rocks. And up at the other side, we have an island known as the Storks, a little rock just showing above the water. Now these are all parts of the same island chain. It's a large basin where the lava flowed out and then sagged in the middle. On the Skerries, we can see that the islands run up at an angle from this side and then drop very steeply to the water. It's exactly the same underneath the water. Exactly the same. In fact, the islands go vertically at the far side, straight down to about 120 feet. Now, because on the outside of the islands we're getting an awful lot of exposure, we're getting the waves coming right down from the Arctic, battering on the outside. It's very, very exposed, and the animals are associated with that type of situation. We've got lots and lots of sponges, lots and lots of colonial hydroids and tunicates, and dead man's fingers. In this situation of great water movement, we find animals particularly adapted to those conditions. Like this very large sponge called Cliona, which was found in colonies up to 4 feet across. Another sponge, Polymastia, lives in much smaller distinct patches, seldom exceeding 6 inches. The whole rock is totally encrusted with various organisms. The plant-like colonies of animals are hydroids and bryozoans. Colonial sea squirts are also very common. A common sea urchin grazes on the encrusting organisms. In patches, the Devonshire cup coral, Caryophylla, a solitary true coral, was very common. One of the characteristic species of this type of area is the soft coral, Alcyonium digitatum, known as dead man's fingers. Filming in these depths requires the use of lights. The rock face has to be examined very closely to ensure that all species present are recorded and collected. The effects of swell in the animals can clearly be seen here, at a fair depth, on a calm day.
Okay.
The other thing, actually, sort of nobody's mentioned this word. An expedition like this obviously does not simply take place without a lot of planning in advance. Yeah,
We'll have to tie that up then.
Yeah, five gallons a day we're going to need at least.
Yes, I've got to make arrangements for an account at this filling station in Portrush. So hopefully then we'll be considered to be account customers, which helps a bit sometimes, doesn't it?
Yeah. Now Robin's coming early.
That's right. Greg I was talking to, and he says he'll be here actually on the Saturday morning, so he'll come straight up to Portrush, so we'll meet him up.
I'll see him up there. Right. Robin, he's supposed to be over during the week so he can give us the stuff, trying to get the gear and things loaded up. All right. Legally, we're obliged to have communication, so I'd rather have that fixed up. So, you know, we'll find some way around. Maybe we're jumping ditches before we come to them. The use of an underwater communication system enables us to be in contact with the diver at all times, to obtain an accurate record of what the diver has seen underwater, and to make maximum use of possible underwater time by using 2 divers only when absolutely necessary.
Everything. You need 2 pots with them. Everything okay?
What about wet foam? Any sign of it yet? What's happening?
Well, no, we've still not actually got it, but they've promised us it this week, so hopefully it should be here. Yeah.
Well, we've got, you know, the last date is this Thursday, in fact. We're testing the stuff this Thursday, you know, so
Yes,
hopefully
right.
it'll be here, you know.
Diver Greg Brown leaving the surface 106.
106. Log sheet.
60.
White House Tower, 56 degrees 52 minutes. Tower Coast Guard Station, 46 degrees 0 minutes.
Hello, Greg. Hello, Greg. Receiving you loud and clear. Are you on bottom? Over.
Depth 80 feet. Depth 80 feet. Over.
Well, wet foam seemed to function not too bad today.
Well, I think we're getting better at understanding what people say rather than actually getting any improvement.
I think the whole thing.
Dave's got the hang of understanding it better than I do.
Maybe, yeah.
Yeah, but I think.
Because I
He
couldn't
understood me
understand
very
Robin
well
at all.
But the thing though is to keep your
It's just
voice
got
down.
to
If you raise your voice at all, I think you're blasting it.
As long as we know that the diver's okay and that they can talk back to the surface and so on.
Yeah, I'd like to be able to get a bit more information on tape. You know, I mean, I'd like if you have more time on the bottom, I'd like to be able to use that time to put more information because you can't hold it. I mean, you know, you can hold some of it, but you can't hold it all. You know, the combination of what's on the tape and the photographs, plus specimens, you should have a fair coverage of what's there. On the inside, we get a lot of different situations, depending on how much current there is.
there's a gut where the water flows through, and in that gut there's a very fast current, and in that we've got a cobbly, bouldery situation with a thing called flustra living on it. Now this is a colonial bryozoan, a polyzoan, and very, very interesting, and lots of other animals are associated with it.
These colonies are made up of thousands of individuals called zooids. Each lives in its own distinct box, but joined to others, forming the colony. The brittle star, Ophiothrix, often lives in dense colonies, feeding by catching plankton on its upraised arms. Its feeding posture can clearly be seen here. To the side of the brittle star community lies a very interesting bed of the horse mussel Modiolus. This bivalve mollusk forms clumps on the sea bed, and many other animals can attach to the mussel shells. It's in this situation that the experienced diving marine biologist really comes into his own, in being able to spot and collect the rarer species. By collection of rarer species, by careful recording of the more common species, and by the use of photography, a detailed and accurate description of a complex community can be obtained. In a large area between the Skerries and the mainland, the bottom is rather barren and is composed largely of almost intact dead shells. The most obvious inhabitants of this area, though by no means common, are predators like this hermit crab living in the shell of a dead mollusk. This whelk has just laid its eggs on an old oyster shell. It's interesting to note that we did not find any live oysters in the area. Plaice are one of the commoner fish species living in these conditions.
Now the current again starts to tighten in. It comes through a gut again and comes into shallower water, and this current speeds up. And because this current speeds up, the sediment is thrown into dunes on the bottom. And these dunes have living in them a peculiar type of sea cucumber called Neopentadactyla mixta. Again, this has been found in other places, but it wasn't known to exist here. And as we spread off that, we go into finer sediment where we get lots and lots of things. Particularly, the most obvious thing we see in this area is the heart urchin, Echinocardium.
These normally live below the surface of sand, moving by the use of specialized spines and tube feet. This small ray lives on the surface, but can very effectively disguise itself.
The most settled area is the area very tight along this side of the Skerries. And this is the area that's completely sheltered. And this is the only area we find mud, or a very, very fine sand. And in this sand we have again animals living particularly adapted to it. We have an anemone called Pichia, which we haven't found anywhere else.
Divers either have to actually dig out the specimens or collect bulk samples of the sediment to determine what's in it.
The other thing there is out there is the sea grass, Zostra, which again is very important and living in two little pockets on this side of the Skerries. Zostra is the only truly marine flowering plant which lives in this part of the world. During the time spent on the survey, more than 100 areas of sea bottom were investigated. Small sediment samples were taken at every site where it was possible, and after drying, the samples were shaken through a series of graded sieves of different mesh size. The different fractions were then weighed, enabling a much more accurate assessment of bottom conditions on the site in question. To achieve a complete picture of the life in an area, it's important to know what organisms live in the region covered and uncovered every 12 hours by the rising and falling tide. Thus, as well as examining the region below low tide by diving, the beaches were also examined, and the intertidal species recorded and collected. Some night dives were also carried out to see if species not very evident during the day would become more obvious by night. This top knot was seen at night, on, or is it under, an overhanging rock, like a fly on a ceiling. This sea cucumber, Cucumeria, seemed to emerge much more at night than during the day. Its body can clearly be seen here, in this case white with lines of tube feet. It's normally hidden in a crevice or under a rock, the only part usually being seen being the tentacles, which emerge to enable the animal to feed. These branch-like tentacles trap planktonic organisms, which are then scraped off at the mouth. This strawberry worm feeds by putting out long, sticky tentacles, to which small particles of detritus adhere. These are then also brought to the mouth and scraped off. This black sea cucumber, Holothuria forscali, was one of the most interesting species we recorded. It feeds by the use of specialized tentacles to graze over rock surfaces. It was not known to exist in Northeast Ireland before this survey took place. Greg is currently involved in producing illustrations for a book on a group of mollusks called nudibranchs. In addition to other work, he found time to draw one or two species he had not seen elsewhere. In work of this nature, a great many beautiful and interesting animals are seen, photographed and recorded, However, perhaps the most important aspect of the work was that by the end of our time at Portrush, we had a fairly full idea of what animals are found in the area. By no means could we pretend to know the complete picture, but we did have a fairly good idea of the general trends and patterns. By carrying out similar work on other parts of the coast, we shall eventually build up a knowledge of what life we have in the sea around us. As we left, the Causeway coast claimed back the world of which we for a short time had been a part.